I'm going to start with question number 1 on paper 1, topic 8. And so it says an aqueous solution of which of the following reacts with magnesium metal. So if you look at your notes, you're looking at this slide right here. This slide has all the different reactions, and you can see right here an example metal. Specifically, it has the magnesium as an example, reacting with HCl. So the answer to that question is letter B, hydrogen chloride. Okay, I'm gonna go down to number 3 next. Number 3 says there's 4 solutions, and it wants to know what is if you listed them in increasing pH, in order of increasing pH, that means the lowest pH first, highest pH last. So definitely lowest pH is going to be one of the acids, HCl, and then the highest one, the last one, is going to be one of the bases. The higher concentration, 0.1 HCl, is stronger than 0.01. So this is going to be first. This is going to have the lowest pH. And then the 0.1 NaOH is going to be stronger than the 0.01 NaOH. So this one has to be last. So 3 has to be last. So the only correct option would be letter B, where this higher concentration acid is the lowest pH and the higher concentration base is the highest pH. So letter B. Number 4 asks which substance can be dissolved in water to give a solution with a high pH and high electrical conductivity. High pH means it has to be a base, and high electrical conductivity means that it has to dissociate really well and give a lot of ions. So it has to be a strong base. So high pH means it has to be a base. High electrical conductivity means it has to be a strong base. So it's not A because A is an acid. It's not B because B is a salt. And it's not C because NH3 ammonia is a weak base, where NaOH is the only one that's a strong base. So I want you guys to look at your blue books and see that there's a list of strong acids and bases and weak acids and bases. You need to be familiar with those. I'm going to skip to number 10. Number 10 asks about which method could you use to determine if a monoprotic acid is strong versus a monoprotic acid that's weak of the same concentration. So basically you're looking for strong versus weak. In other words, which one gives you more reaction? The one that gives you more reaction is going to be the strong. The one that gives you less reaction is going to be weak. So of the things that it asks you to do, the first one, you would be looking at formation of gas bubbles. More bubbles means stronger acid. The second one talks about measuring the temperature change. Larger temperature change, stronger acid. And then for the last one, it asks for you to hook it up to a battery and a lamp and see how the brightness of the lamp. The brighter the lamp, the stronger the acid. So basically, you could do a comparison of gas bubbles, of temperature change, and the glowing of the lamp. So all 3 are options, and so the answer is letter D. Number 12, which one is not a strong acid? To answer this question, you're just going to have to be familiar with the fact that nitric acid, sulfuric acid, and hydrochloric acid are all strong acids, and carbonic acid is not. And you have to just basically look at those lists of strong acids and bases and weak acids and bases from the textbook, from the blue book. If I go to number 15, 15 asks about taking hydrochloric acid, which is a strong acid, and ethanoic acid, which is a weak acid. So they have the same concentration, and they're going to both completely react with 5 grams of calcium carbonate. Which of these statements is correct? The fact that it says that they both reacted completely, it means that the answer ends up being letter D. The same volume of carbon dioxide was produced with both acids, and that's because it says that they both reacted completely. So there's not going to be more volume produced or less volume. It's going to be the same amount of volume because the reaction reaches completion. Which acids are strong? Oh, no, I'm sorry. 16 is the same as number 15. So I skipped it. So I deleted it because it was the same. 21 was the same as 4, so I deleted that. And so I'm going to go to 22. And again, these are all based on questions that you guys had for me. And please, any questions you guys have, I want you guys to ask. Which methods will distinguish between equal molar solutions of a strong base and a strong acid? So the answer here is letter A, 1 and 2 only. And the reason is you can measure the amount of gas bubbles and do a comparison. If you end up with equal amounts of gas bubbles, then you would be able to determine equal molar solutions. You can also measure the change in temperature. With this one, number 3, it's not the correct answer only because if you connect it to a voltmeter, but this doesn't say it's connected to a voltmeter, so you wouldn't know, you would just be looking at the brightness. So you wouldn't be able to know if they're equal molar. So you need quantities, okay? And so the answer is letter A, 1 and 2 only. All right, any other questions? Let me know.